Okay, so this is lesson 4.6, which is substitution part 2. And so the reason that we switch this into 2 lessons is because sometimes the questions are straightforward like this, where x is very obviously isolated, and so you can easily substitute this into the first equation. Okay? However, they're not all like that. In these systems, there are no variables that are by itself. So you must first solve for x or y, and then solve the system. So you want to be smart about this. And when looking at this, the first thing I look for is, are there any variables that are already by itself? And so the answer is no, because they all have coefficients. Then I look and see, well, is there one that if I just did one step, I could easily isolate it? And that would be the second one, because if I just divided everything by 4, I would isolate x. So I'm going to isolate x in the second equation. So just going to quickly circle that so I know what I'm isolating. I'm going to divide every single term by 4. I'm left with x equals 2y minus 7. So now that I've isolated x, I'm going to substitute it into the other equation. Negative 4x plus 5y equals negative 11. I'm going to solve this at x equals 2y minus 7. So now this becomes exactly like the previous objective. I'm going to substitute this in for x. So everywhere that I see an x, I'm going to substitute 2y minus 7. So negative 4 times the quantity 2y minus 7 plus 5y equals negative 11. Okay? I'm going to go ahead and I'm going to distribute a negative 4 to both of these, making this negative 8y plus 28 plus 5y equals negative 11. Combine like terms. So I'm left with negative 3y plus 28 equals negative 11. I'm going to subtract 28 from both sides. Negative 3y equals, signs are the same, so I add the numbers, keep the sign, and then I'm going to divide by negative 3. Y equals a positive 13. Okay, so let me go back to the beginning here. I'm going to write blank comma blank because 13 is our y coordinate, so I'll go ahead and substitute it into the second slot. Now I'm going to take y equals 13 and I'm going to substitute it into one of the two equations. And I'm going to choose the second equation. 4x equals 8y minus 28 at y equals 13. So I'm going to substitute 13 in for y. This becomes 4x equals 8 times 13 minus 28. Now, I don't really want to multiply 8 times 13, so I'm actually going to choose to divide everything by 4. Because 8 divided by 4 is 2. 7. Now, 2 times 13 is 26. And 26 minus 7 is, what is that? 15? No, 19. X equals 19. So my final answer, 19, 13. Okay? For number 3, let's talk about which variable you should isolate. So you see we have 2x minus y equals 1 and 2x plus y equals 15. In situations like this, you want to choose the variable that has a positive 1 as a coefficient. So you see here this is a negative 1, and then this one's a positive 1. So I'm going to choose to isolate y in the second equation. So I'm going to go ahead and subtract 2x because I'm isolating y. And you're left with y equals a negative 2x plus 15. That was easy. That only took one step. Take this and I'll substitute it into the first equation. 2x minus y equals 1 at y equals negative 2x plus 15. So everywhere that I see a y, I'm going to substitute in the quantity 2x plus 15. So 2x minus the quantity negative 2x plus 15 equals 1. Don't forget that you're distributing a negative 1 to both parentheses. This becomes 2x. Negative 1 times negative 2x is a positive 2x. Minus 15 equals 1. Combine like terms. Add 15 to both sides to isolate our variable. Divide both sides by 4. And you get x to equal 4. Come back to the beginning. X is 4. Now I'm going to substitute x equals 4 into either equation. I'm going to choose the second equation. But it doesn't matter which one. And everywhere that I see an x, I'm going to substitute 4. 2 times 4 plus y equals 15. Subtract 8 on both sides. Y equals 7. Now in our very last one, I'm actually not going to solve it. I'm just going to set it up. And the first thing is I had a typo. This should be a negative 10. So when looking at this one, you want to look and see what variable do I want to isolate. Okay? If you look at the second equation, if I were to divide everything by 5, man, that would give me some nasty numbers. If I were to divide everything by 6, that would give me some nasty numbers too. So I know I'm actually not going to isolate any variables in the second equation. Looking at the first one, I see that there's a 2x plus 4y equals 26. All of these numbers are even, so that's actually really going to help me out. Now what do I isolate, the x or the y? Well, if I were to isolate the x, I would subtract 4y on both sides. And then divide by 2, which gives me x equals negative 2y plus 13. This looks awesome. I can work with that. If instead I would have divided everything by 4, so I first would have subtracted 2x from both sides. When I divide everything by 4, see, they're not evenly divisible by 4. So y equals negative 1/2 x plus 26 divided by 4. This doesn't look fun. So what you want to do is you want to look and see what number can I divide evenly into all of them. So 2 goes evenly into all of them, so I'm going to choose 2. Now you would take this and substitute into the second equation. So I'm going to solve this at x equals negative 2y plus 13. So everywhere that I see an x, I'm going to substitute negative 2y plus 13. You're going to go ahead and you're going to distribute the negative 6 to both. Positive 12y. Negative 6 times 13 is 78. Combine like terms. Add 78 to both sides. Divide by 17. Now this looks awful, but it's really not that bad. 17 times 4, I believe, is 68. 4 times 7 is 28. 4 times 1 is 4, plus 1 is 6. So in our answer, y is 4, and you can go ahead and substitute back in for the very last answer.